Starting with example 6 here in our notes, we've got a lot of questions for the one answer. Wants to know what is the base of this function? Well, this is a natural log, and a natural log is a known base e. So this is a base of e. What is the horizontal and or vertical shift? So when it is in parentheses, when it is inside the log, it's shifting it left and right because this is a minus 8 just to the right. So right 1. What is the domain? To find the domain, you're going to take what's inside parentheses and make that greater than 0. So add that over, and x must be greater than 1. Or in interval notation, that's 1 to infinity. So this is a new one. What is the range? If you look at 2 pages before when we were talking about domain, we said that the range is always going to be negative infinity to positive infinity for a log, because an exponential, its inverse, has a domain, but is all real numbers. Now, if you can't remember that, pull that up, type it in, and as you go from the bottom to the top, it's going to go down forever, so negative infinity, and then it's going to keep going over and up. There's an arrow right there, so positive infinity. Okay, where is the vertical asymptote at? It is at x equals 1. It's where this starts. And again, you can use your slide, and there it is. That undefined is right there at 1. So it's going to stop sliding. Okay, so besides the range, that's what we did on examples 4 and 5. But now it's wanting me to find the inverse. So to find the inverse, I'm going to go ahead and just rewrite this. Step 1 is to rewrite f of x as y. So we have y equals the natural log of x minus 1. Step 2 is interchange your x and y. So x equals the natural log of y minus 1. Step 3 is to solve for y. Just like before, when I have no way of solving an exponential or a variable in the exponential position, I have no way of solving for a variable inside of a log. So rewrite. This is again a base of e. So we're going base to the other side of the equals. So this is e to the x, and it equals what's left over, or what's inside the log, y minus 1. Okay, so now I can solve, but I haven't solved yet. How do we get y by itself? We're going to add that 1 over. So I have e to the x plus 1 equals y. To get full credit, step 4 is to replace y with your inverse function notation. The inverse of f of x is e to the x plus 1. So what is the base of my inverse? Not wanting to stay, okay. So the base of this is now an exponential with a base of e. So whatever the base is of your inverse is going to be the same base as your function. What is the horizontal and or vertical shift? When this is outside of the function, even though these are logs, it's the exact same thing, right? This function can change to anything. It can change to a, I was going to say a quartic, which is true, but a quadratic. It can be a cubic, it can be a square root, it can be an absolute value. This function can change. But when I have something added outside of that function, that's going to go up. So this one goes up 1. So notice here, the first one went left and right. Now we're going up or down with that inverse. For the domain and range, we have 2 options. We can type in this into Desmos and use the graph, but remember the domain is the same as my range. So that is negative infinity to positive infinity, because that's what my range was here. Okay, or every exponential has a domain of all real numbers. So then what is the range? The range is the same as my domain of the function. So it is 1 to infinity. Okay, and it's 1 to infinity because this has been moved up 1. We have a horizontal asymptote at y equals 1.